Let's talk about the pipe that moves the air between the different components in a ventilation system. That is the ductwork or the ducting. We've been talking about the different components of a ventilation system. We've talked about the hood so far. Hood can also be referred to as the capture inlet or inlet. But ductwork, again, the pipes that carry all of the it connects everything together within the system. They can be rigid, they can be flexible. They connect the hood to the fan and the fan to the outlet stack. If you really want to get simple, that's what you have in a ventilation system. You have a hood, the ductwork to the fan, and then the ductwork from the fan to the outlet stack. But most industrial ventilation systems aren't going to be quite that simple. There's going to be, the ductwork itself can be very complicated with a lot of different components. You're going to have the main duct with multiple branch ducts connected to multiple hoods. You're going to have multiple capture inlets in your typical industrial ventilation system. The components of duct systems can include square or round ductwork. Round pipe is most common for industrial applications. It's most efficient. You can have Y fittings that should be 30 to 60 degrees, should not be less than 30 or greater than 60 degrees for the best efficiency. Elbow fittings. Oh, one thing about the Y fittings I need to mention. I'm going to talk about all these some more and throw out some other information about each of these components as we move along. But one thing about Y fittings, they're going to be used to connect the branch ducts to the main duct that runs through the system. Elbow fittings are those that are at a 90-degree angle. Reducers may be used if you need to change from one size of ductwork to another, either up or down. You're going to have reducers involved. Blast gates, they're used to open or close branch ducts or open or close different portions of the ventilation system. Then you're also going to have plenums, or think of a plenum as like a junction box where multiple ductwork or ducts come together in one location. Here is a typical ventilation system that you might see in a commercial woodworking shop. Pardon me, I do talk about woodworking a lot. That's kind of a hobby of mine. I don't have anything like this. I wish I did. And this is more of a commercial arrangement. They have their main duct system. Go ahead and bring this up. The main duct system. Then they have their branch ducts off of the main. It looks like they have 3, 4, 5. There's probably one I'm missing in there. At least 5 branches off of the main duct. Now, in a system like this, there's not going to be any return air components. The makeup air that's needed for the system to work properly is supplied through natural openings in the building's envelope. Most buildings, unless they are really built intentionally to be extremely tight, they are going to have natural air infiltration, which for some ventilation systems, that natural air infiltration will provide enough makeup air. If the building is a tight building and makeup air is needed, they could open windows, or they could add components to the system so that adequate makeup air is provided. And we are going to have one video or one significant discussion of makeup air later on. I just threw this out here as we're looking at this particular example. Normally, if we're talking about an industrial operation like this, the material that is collected in the system is going to be exhausted outdoors into a dust collector that's located outdoors. And we'll talk more about dust collectors when we talk about air treatment systems. As far as duct size and shape, round is preferable for industrial ventilation. With round ducting, there's less friction than square or rectangular ductwork. Less friction, more efficiency. Larger ducts also are more efficient, also will create less friction, allow more air volume to work or pass through the system. If the system has smaller ducts, it may actually require more powerful fans to move the required air through that smaller ductwork system. You can also get ductwork that is ribbed or smooth. And you probably guessed that smooth is going to be more efficient. But ribbed ducting is used in some applications because of its flexibility. We saw a portion of this picture earlier in the first video, I believe. This is some ribbed ductwork, and the ribbing allows it to be flexible, allows some degree of portability with the duct. And if you have flexibility in the ductwork, that gives you flexibility in where you locate your capture inlet. So even though the smooth is more efficient, there's application, it is possible to use flexible ductwork in industrial systems. Also, back up here, even though round is preferable, you will see industrial ventilation systems utilizing square or rectangular ducts as well. And you'll see ventilation systems that have undersized or smaller ducts. Think of these as best practices in ventilation system design. They're not absolutes. You can get away with deviation from these best practices. When it comes to duct fittings, it's best practice to avoid 90-degree elbows or T-fittings. Here's our 90-degree elbow, here's our T-fitting. Your system can still work, but it's not going to be quite as efficient if you have 90-degree turns. If you're changing the direction of the air so dramatically, like you do with a 90-degree elbow, that's going to affect the efficiency. Same thing with a T fitting. With a T, you basically have two 90-degree elbows going on. If elbows are used in your system, the elbows should be located at least 5 diameters from an inlet or an outlet. For example, if we're using 8-inch duct, the elbows or T's also should be at least 40 inches from the elbows or the T's. Again, 8-inch duct, outlets and inlets at least 40 inches from elbows or T's. Again, that's going back to what we talked about in an earlier video about how diameter is a measurement unit in a sense. If our ductwork is 8 inches, one diameter in length is 8 inches, 2 diameters, 16 inches, 1.5 diameters, 12 inches, and so on. Our branch ducts should angle off at 30 degrees to 60 degrees for a best practice. Here we have a Y fitting. Here we have just a more conventional branch duct configuration, and that would be approximately 60 degrees there. Blast gates also can be thought of as a duct fitting. They need to be positioned to eliminate airflow and unused branches. We're going to talk more about blast gates and dampers before we're done with this video, but that's the purpose of a blast gate, to control airflow through the system. If we have elbows in our system and we want to make sure that they're positioned properly relative to the fan, we should follow the 3 and 6 rule. The distance between the elbow and the fan inlet should be at least 6 diameters. The elbow and the fan inlet, at least 6 diameters. The distance between the fan outlet and the elbow should be at least 3 diameters in length. If following this rule according to this diagram that we have here, and we're using 8-inch duct, the section of straight duct on the inlet side here should be 48 inches. Again, remember, these are best practices for best efficiency. On the outlet side, 3 diameters from the fan, 24 inches on the outlet side between the fan and an elbow. And again, like I've said multiple times now, you're probably not going to be designing these systems, but having these little tidbits of knowledge can help you better understand systems that you may be working with in a facility. Also, if you're in a meeting and the engineer's talking about their design for the ventilation system that they're going to be installing, you having this, these small bits of knowledge can be beneficial. For example, let's say you have an engineer comes in, and engineers aren't above making mistakes. Let's say they have an elbow that's only 3 diameters from the fan. That might be something you want to ask about. Be careful how you ask the question, but you might want to ask, is that enough distance between the elbow and the fan? Don't go in like you know it all and that you're going to teach him about ventilation system design. But simple question: is that enough distance? Can you explain to me why that's enough distance? Would it make any difference if the elbow were further from the fan? Whenever you can use questions instead of making statements, that's going to make you seem less arrogant in settings like that. So ask questions. Don't go in saying, "Hey, in the textbook it said, the textbook that I studied for industrial hygiene, it said that it had to be 6 diameters from the fan." Don't go in with that approach. Ask questions about whether it's good enough. Is that adequate? Will that affect efficiency? And see how they respond. And there may be a good reason. There may be some reason in the design for violating the 3 and 6 rule. But it doesn't hurt to have them explain their reasoning or their thinking for locating the elbow where they located it in their system. Again, these are best practices. They're not absolutes. When it comes to blast gates and dampers, these devices allow portions of the duct system to be closed off, unused portions. They're going to normally be located at branches, and we're going to use these, like I said, to close off unneeded branches, which is going to increase efficiency of the active branches. Here are several different blast gates, different sizes. They're all pretty much the same design, but just different sizes. Now this is a remote controlled blast gate. This is ideal. If you can have remote controlled blast gates, that allows you to open or close branches without getting the ladder out or without having physically open or close the blast gate. You can do it from a distance. An example of blast gate usage in an industrial wood shop. If we have branches off the main duct that connect each tool to the local exhaust ventilation system, we are able to close off the table saw when it's not being used, or the jointer when it's not being used, or the bandsaw. Anything that's not being used, we can close off that branch that goes to that tool. That's going to increase airflow. It's going to increase efficiency of the system, so that the tool that is being used, say the planer that is being used, the system's going to do a better job of sucking up the chips and the dust from the planer operation. If those other branches were open, there's going to be wasted efficiency because of the air moving through those other branches. Close off the ones that aren't being used. It's going to make for better, more efficient collection. All right, that's enough for this video. Just give you a little bit of knowledge about duct work. When we come back in the next video, I'm going to talk more about exhaust and treatment systems, if we need them in our ventilation system. Look at some different types of treatment systems, and we'll talk about when we need them and when we can get by without having a treatment system.